Alright, hi everybody, it's Mr. Marba, and yesterday after watching the video on funky exponents, I asked you to try and see if you could work on Exploring Exponents Part 1, and basically on this you're just filling out tables. Each table has the beginning of a pattern, and I just wanted you to try and see if you could continue that pattern all the way through the rest of the table. So I'm going to start with table A. I'm going to start doing the easy part of table A, which would be to continue this pattern here. Obviously, you've got 4 to the first power, second power, 4 to the third power, 4 to the fourth power. So we know we're going to have 4 to the fifth power, 4 to the sixth power, 4 to the seventh, 4 to the eighth, 4 to the ninth, and then 4 to the 10th power. Over here, basically what we're doing is writing what that means. 4 cubed means you've got 4 times 4 times 4. Why are the ones there? We'll talk about that in a minute, but this should be easy to fill out. I'll try to do it quick. 4 times 4 times 4 times 4 for 4 to the fourth. 4 to the fifth would be 1 times 4 times 4 times 4 times 4 times 4. And 4 to the sixth would be 6 fours, etc., etc., etc. I don't think I need to write those in for you to know what happened there. Then, in the product column here, all you had to do was just use your calculator and come up with what those answers were. So, basically, you were just hitting times 4 to get 256, and then hitting times 4 to get 1024, 4096, and as you can see, they started to get bigger pretty quick into the multiple thousands and even hundreds of thousands, and eventually even into the millions when we got down to the very last box. So you can check and see if you were on the right track there. This one was basically the easy one here. The only thing we didn't really fill in was this box right here, and I guess if you follow this pattern of the powers, what number comes before 4 to the 1 power? 4 to the 0 power. And that's why we wrote the ones in here, so that you could see that 4 to this power of 0 equals 1, which is interesting. And we'll talk more about that later, although I think you saw an explanation in the video yesterday on that. Okay, table B. For table B, we've got powers of 3 instead of powers of 4, but what's weird about table 3 is instead of it being a growing pattern, it's a shrinking pattern. So you've got 3 to the fifth, 3 to the fourth, third, second, first, 3 to the 0. What comes next if you're going descending? I guess we would have negative exponents here. Are you allowed to have a negative exponent, a negative power? I guess so. What does that mean? Well, in order to know what negative exponents mean, let's follow this pattern. What's happening each time here? Aren't you basically dividing by 3 each time? So if you do 3 divided by 3, what are you going to get? 1. That kind of tells us again why something to the 0 power equals 1, which is interesting. But this is also going to help us figure out what negative exponents mean. We said you're allowed to have negative exponents, but what do they mean? Well, what's the pattern? We're going to take this number, and what are we going to do to it? Divide it by 3. That's the pattern. So, how do you write 1 divided by 3? You could write it as 1 divided by 3. Or, better yet, 1/3. And then, what's 3 to the negative 2 power going to be? We're going to follow the same pattern and divide by 3. So we're going to have 1/3 divided by 3. which is another way of saying 1/3 of 1/3, or it's a 1 with 3 times 3 in the bottom. Hopefully that kind of makes sense. So that when we have 3 to the negative 3 power, you've got this 1 over 3 times 3, and then you're going to divide it by 3 again, so you're going to have 1 over 3 times 3 times 3. So notice 3 to the negative 3rd power means there are 3 3's. But where are those 3 3's? Those 3 3's are in the denominator. And what's on top? The number 1. So without having to do any math, can I guess what 3 to the negative 4th power is? It's a 1 on top with what on the bottom? 3 times 3 times 3 times 3. And what's 3 to the negative 5th going to be? It's 3 to the 5th. But it's 3 to the 5th in the denominator of a fraction with a 1 on top. Interesting. Now you can see why we put the 1's, right? All the 1's here, because you need those 1's to show that 3 to the negative 1 is 1/3, and 3 to the negative 2 is 1 over 3 squared, and 3 to the negative 3 is 1 over, 3 cubed, and 3 to the negative 4 is 1 over 3 to the 4th power, and so on. I wonder how many of you got that when you were trying this on your own yesterday. If you didn't get it on your own, that's fine. That's why I'm showing it to you right now. This 3rd column should now hopefully kind of make sense for what we're going to do with this. So each time we've got 1 less 2 until we eventually divide by 2 like we've been doing each time. And 2 divided by 2 is not 0, it's 1. So anything to the 0 power is always 1. So we go 32 divided by 2, divided by 2, divided by 2, divided by 2. What's 1 divided by 2? 1/2. So 2 to the negative 1 power is 1 2 in the denominator. 2 to the negative 2 power is 2 2's in the denominator, so it's 1/4. 2 to the negative 3 is 3 3's, but where are those 3 3's? In the denominator, so it's 1/8, and I don't know if you see the symmetry here, but 2, 2, 4, 4, 8, 8. We kind of know this is going to be 1/16 and then 1 over 32. Why? Because 2 to the negative 4 is 2, 2, 2, 2, all in the denominator, and 2 to the negative 5 is 2 times 2 times 2 times 2 times 2. It is 2 to the 5th, but it is 2 to the 5th in the denominator. So now what I would like you to do is I want you to take your answers from this and start to answer the questions in Exploring Exponents Part 2. Basically, it's going to ask you, look at Table A. What's happening in this column? What's happening in that column of Table B, Table C? And you're going to describe the patterns that you saw. What I really want you to make sure that you're grasping on this is, does a negative exponent result in a negative answer? So when we had negative exponents, did we have negative answers? No, we did not. So, does a negative exponent result in a negative answer? No. Negative exponents don't mean negative answers. What do negative exponents mean? That's the next question on the next page. What do we notice about negative exponents? Negative exponents mean what? What do negative exponents mean? Negative exponents mean powers in denominators. Denominators. powers. Powers in denominators. So what does 4 to the negative 3 power mean? That means you are going to do 4 times 4 times 4, but where are you going to do it? In the denominator. And therefore, I think you should be able to finish and complete the rest of this on your own. Thanks for listening. And I will see you around in our next video. See you next time.